Good afternoon, class. We are group 11 from section 32, and today we will present on the topic solving systems of linear equations using Gauss-Jordan method. So what is Gauss-Jordan method? Gauss-Jordan method is also known as Gauss-Jordan elimination, and the function of this method is to solve systems of linear equations and to find the inverse of any invertible matrix. And this method relies upon three elementary row operations. So when we are given a equation like this, we need to form augmented matrix first. So by forming augmented matrix, we'll get the matrix in this form. And the second, we need to perform row operations to obtain reduced row echelon form. So the operations for this equation, the first we need to get the 0 for the second row, the first value. So how to get a 0? We use the row 2 minus 2 row 1. And the row 2 will become 0, 1, 3 and negative 2. So next we'll perform this method again on this value. So we use row 3 minus 4r1, and the next we need to do it again for this value. So row 3 plus 4r2, and for this value we need to get 1 because we need to obtain the reduced row echelon form. So this value will divide by 13 for this row. The next, perform the method again, the row operations, to get 0 for this value. So it is r2 minus 3r3. And for this value also, r1 minus r3. And for this value. So now we get what we call the reduced row echelon form. So when your matrix is in this form, we can obtain the value of x, y, z, which is 3, 4 and negative 2. So that's all for my part. Thank you.
So this is our linear equation whereby x plus y plus z equals to 4, 2x minus 3y plus z equals to 2, negative x plus 2y minus z equals to negative 1. So now we will insert 1, 1, 1 from the first and 4 from the first equation, and 2, negative 3, 1 equals to 2 from the second equation, and negative 1, 2 and negative 1 and negative 1 from the third equation. So now we will try to find a 0 everywhere else. So first we will use negative 2 multiplied with row 1 plus row 2 equals to the new row 1, and row 1 plus row 3 equals to the new row 3. So from this step, we will find that negative 2 multiplied with 1 plus 2, we will get 0 here. Negative 2 multiplied with 1 plus minus negative 3 will get a negative 5 here. Negative 2 multiplied with 1 plus 1, we will get a negative 1 here. And for this equation, we will get 1 plus negative 1, we will get a 0 here. 1 plus 2, we will get a 3. 1 plus negative 1, we will get a 0. And 4 plus minus 1, we will get a 3 here. And for the next step, we will interchange row 1 and row 3. So for the next step, you will saw that the row 3 and row 2 interchange the position, and the next step we will use the second row divided by 3 to get a new row 3. So from this equation whereby the row 2 will be divided by 3, we will find that this number 3 is divided by 3, we will get a 1, and 3 here divided by 3, we will get a 1. So the next step will be negative 1 multiplied with row 2 and plus row 1, we will get a new row 1, and 5 multiplied with row 2 plus row 3, we will get a new row 3 here. So from the question here, we will find that negative 1 multiplied with 0 plus 1, we will get a 1 here, and negative 1 multiplied with a 1 here, we will get plus 1, we will get a 0 here, and negative 1 multiplied with 0 plus 1, we will get 1 here, and negative 1 multiplied with 4, with 1 plus 4, we will get a 3 here, and 5 multiplied with 0 plus 0, we will get a 0 here, and 5 multiplied with 1 plus negative 5 will get 0 here, and 5 multiplied with negative 1 plus negative 5 multiplied with 0 plus 1, we will get negative 1 here, and 5 multiplied with 1 plus negative 6 will get a negative 1 here. So now we will be using the last step, whereby negative 1 will multiply with row 3 plus row 1 equals to the new row 1. So from here we will find that negative 1 multiplied with 0 plus 1 will get a 1. Negative 1 multiplied with 0 plus 0 will get a 0 here, and negative 1 multiplied with negative 1 plus 1 will get a 0, and negative 1 multiplied with negative 1 plus 3 will get a 2 here. And so from this final equation we will find x, y, and z, whereby x will be 2, y equals to 1, and z equals to 1. And that's all from this question. Thank you.
Hi everyone, I'm Chai Jijian and I'm the student from the UTN and taking the course of Radical Engineering. And this video I would like to share about the way to solve the linear equation by using the Gauss-Jordan elimination method. So for this linear equation, we need to convert it into the matrix form first, where is 1, 1, 1, 1, 2, 3, and 1, 3, 6 for the left side, and the right side is 2, 6, and 13. So next, we need to do for this 3 become 0, this 3 becomes 0, and this 3 become 1. Where is we can use the negative R1 plus R2, negative R1 plus R3. So the R1 the row 1 remain the same, where is 1, 1, 1, and 2. So now the row 2, negative 1 plus 1 becomes 0, negative 1 plus 2 becomes 1, and negative 1 plus 3 becomes 2. So the negative 2 plus 6 becomes 4. And the row 3, negative 1 plus 1 becomes 0, negative 1 plus 3 becomes 2, negative 1 plus 6 becomes 5, negative 2 plus 19 becomes 11. So next, we convert this to become 0. So it's negative 2R2 plus R3, we can use this. So the row 1 and the row 2 remain the same. So the row 3 will become 0, 0, negative 4 plus 5 become 1, and negative 8 plus 11 become 3. So next, we need to we can convert this to 0 first. So you can use a negative R2 plus R1. That is 1, 0, negative 1, and negative 2. So the other remain the same. So, and the next this 2 becomes 0. We can use R3 plus R1, and also negative 2 R3 plus R2. It will become to 1, 0, 0, 0, 1, 0, and 0, 0, 1. And the right side is 1, negative 2, and 3. So now we finish the Gauss-Jordan method. We can get the answer directly, where it is x equal to 1, y equal to -2, and also the z equal to 3. That's all for me. Thank you.